Welcome to Brain Vision.
So we have this pulley, and it's attached to this other pulley. And this is attached to a fixed point on the wall. And this is fixed as well. So we have, both of these have a radius of r. And I'm going to call this one B, and this one A. So we start with our givens, which is our t is equal to 3 seconds. Our m is equal to 6 kilograms. Our r is equal to 0.125 meters. And we're being asked what is the velocity of the center of mass of B. Okay, so there's a mistake in the problem because it's asking for the velocity of the center of mass of B, which is clearly 0. It is fixed by definition. So we want to find the VA. That's what the answer book has. So we're going to look for VA. So VA, we're going to first sum our moments about B. So actually, we're going to do some kinematics first. We have W omega, we have omega B, right? We have omega B. We have VAB. So VAB is equal to R times omega B. We also have this cylinder A that has this point C around which it is rotating. It has some omega A, and it has a V of A. So omega A is equal to VAB over 2R. Which is also equal to 1/2 omega B. So now we're going to erase this stuff. We're going to move our image over. Over here. And next we're going to start solving this problem. So we have our moments. Let's draw this circle. We have our moments about B. So we have some force here, and we have a PT. This is the impulse being imparted on it. So our moments about B show us that 0, which is the initial angular momentum, plus PTR, which is the impulse, is equal to the final angular momentum, which is I omega B. Now let's look at our second cylinder, which has upwards force being applied of P, and an upwards force here of Q. So, and it has in the center a downwards force of mg, and then we have C here. So we're saying moments about C. We have 0 minus 2ptr plus mgtr is equal to mva r plus I omega A. This is RA. So we have so we're assuming the PT is equal to QT, and that is creating this this moment about the center. And we also have mgt, which is being applied right here. Oh no, sorry, this is just 2 times the radius. So this is not acting to make any rolling motion about C. So we have 2 pt times r, which is 1 impulse. Then we have this impulse, which is being applied at a radius r. And this is equal to the translational momentum plus the rotational momentum. So now we have to solve for, we have to solve for VA. So let's get to work. We have 2I omega b so we're subbing in 2 I omega b from up here, so that's negative 2I omega b. So now we have minus mgtr is equal to, we're going to sub in the stuff that we know before. So we have VARA. We're going to sub in 1/2 r squared omega b plus I times 1/2 omega b. So now we're going to solve. We're going to notice that we're going to get 5/2 mr squared over 2 plus 1/2 mr squared omega b is equal to mgrt. And then we get 7/4 r omega b is equal to gt. Or just gt. Now we're going to solve for omega b. So that will give us 4/7 gt over r. And so VA is equal to 1/2 r omega b. So that's going to give us 2/7 gt. So that's VA is equal to 2/7 times 9.8 times 3, which gives us a speed of 8.41 meters per second. Next, we want to solve for B, which is the tension force between the 2 spools. So fortunately, we can use some of the information that we already have here. So we're going to use this equation right here. So PTR is equal to, we now know omega b is equal to 4/7 GTR, or GT over R rather. So that gives us, we can cross off these guys. And now we have P is equal to 4/7 IG over, actually we're not going to cross that off, we're just going to have this IG over R squared. This is equal to 4/7 times mg. Since I is equal to 1/2 mr squared. So now we have 4/7 mg, which is 4/7 times 6 times 9.8. So we get a force of 33.6 newtons.